some brief introduction about me. So my background is in physics. I obtained PhD in biophysics and started my scientific career, but then I decided to switch to IT because I was really interested in how to build things and program and work with clusters, distributed systems. So I switched to IT in 2000, about 10 years ago already. Worked in several companies. Some of them you know. And 2 years ago, I had to relocate to Estonia so I can join Microsoft. And yes, I have some channels that you can subscribe where I'm sharing my interesting topics which I think they are interesting, especially for me. So I'm sharing this in Telegram, so you can join there. Okay, I will try louder, but usually I'm very quiet speaker. Okay, so what I'm going to talk today is kind of a summary of my experience for last 3 to 4 years. I tried to combine it as some group of best practices of some, or combines them under some umbrella of data quality, data monitoring, and DevOps best practices, how to implement all this stuff. So why the name? First of all, why the name is boring data engineering? Because all of us usually want to write code, do exciting things. Like we don't like to prepare, set up some systems, and also not often we like to monitor stuff, make sure everything quality is in place. But this two processes before the beginning of building your pipelines and the post-delivery processes like data quality monitoring, they are quite often neglected, but without that you cannot have really high quality data solution. So I will talk about these stages and how to build data pipelines. I think it's a more common thing and you can find it, or how you work with your you prepare for your machine learning modeling and so on, how you work with data. That's more common topic. So I will talk about these two separate concepts. So we will talk about like how we apply DevOps best practices to data engineering, how we can combine everything with, how can we have everything as a configuration, as a code, everything as a code, and what are the benefits of doing that, how to deal with the change management in data engineering, and after this, preparatory stages, what are the other stages like as data monitoring, data quality, data observability, and I will also show a very simple solution, very basic data quality solution. So let's start with just to catch up. What is data engineering about and how it overlaps or interacts with DevOps? So the main core fundamental part of DevOps that I specified are these 5. Of course, there are some topics about agile and other processes, organizational stuff, but I will talk about these 5 and how they affect data engineering. So first of all, just to recap, the DevOps, it's very important part is the version control, something like Git. Without that, we cannot track anything historically and go back and change whatever revert. Basically, this is something that we don't even talk about. That this is like an air for us now. Other very common things that sometimes people are mixing with each other or mistaken, it's the continuous integration and continuous delivery. So the continuous integration is automation process where you have to test and validate all the changes before merging them with the main production branch. So if you are working on a feature, you're adding a new pipeline, then you have to make sure that you have a process is automated, not that you just test on your laptop or whatever. That make sure that the code that you are going to add will not break anything and will work. And finally, continuous delivery is again actually, continuous integration is part of just one part of continuous delivery, but continuous delivery is the process where you automate the delivery of the software, delivery of the builds or artifacts, whatever. So it's, again, you don't mess manually in your production, you don't drop something manually, but we all know that this is happen even in very big tech companies like I saw that, so this is also important. And finally, infrastructure as code is another like growing and becoming popular direction where you don't manually deploy cluster, you don't manually create the database, but it's done through a code, through a configuration, which is then is triggered using some APIs which clouds provide, or even some on-premises services allow this to do it. This is that functionality, and obviously monitoring, which nobody likes to care about, and it's something like, okay, somebody like DevOps will do, they will do it, we don't care about it. We shipped our pipeline, it doesn't work, but nobody cares. So, and what are the main topics in data engineering that can be affected by this DevOps disciplines? So obviously data and metadata in terms of quality, and not only data stores, whether it's a data warehouse, database, data lake, obviously data pipelines themselves, so the main meat, and finally also data analysis, which is, you can say it's a part of data analytics, but still it's very it's still part of one process. And the last thing that we will talk a lot today, and which will be probably the umbrella topic of all this discussion, is data quality. It's very growing now. There is trends. There are like trends about data quality, because finally people understood that it's not about the volume of the data that is flowing, but actually, can you trust this data? So my concept is I like to have everything as code. What we are talking about? So basically, that start from this first two concepts of DevOps: version control and infrastructure as code. Let's take this and extend them. So one of important thing about having version control in data engineering setup in the solution is that not only we care about the code, we must care about the data. And as you change the code, it affects how your data is changing. It's maybe simple, but basically you want to understand at each point of time the data that you are looking at. What is the code behind this data that is generating it? And why is something wrong? For example, you open the dashboard and something wrong, so you see that this metric is obviously wrong. Why this is happening? Can we go back and track what change was done at which part of the system? There is another interesting direction growing, maybe especially for data scientists. Maybe you heard about it, data version control of data. This is a different topic. We are talking about the version control of data config or of code. It's not the version control of data itself. But this is the very similar to the idea that we have in machine learning, that in machine learning, if you have a model, but you don't know what was the data behind that model that it was trained on, this model is quite useless, in my opinion, because you cannot understand is it optimized for this data set, how can I reproduce the experiment, how I will compare this new model. If I have new model and new data, this is really different things. You should have that data, all data as well, so you can compare. So, but here we want the same applies to data engineering. You want to have the code and the data. You should always know at each point of time what was the code. So, and we start in this layered manner. So it's like Armenian pahlava or something like that. We start with the layers. So the first layer is infrastructure. This we borrow from the DevOps methodology. We want everything to be configured in our cloud, obviously in the cloud. I mean, in on-premise, it's very hard to have such setup, but again, even on-premise solutions provide APIs that you can configure it as a code. You don't go manually and say, I need a new cluster, and then you go click, 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 and nobody knows how you did that, when you did that, and so on. Everything should be as a code, and this will serve as a foundation for the next stage, so we can automate this process. But we should first have to write down this code. The next stage, obviously, pipelines, your, I don't know, your Spark application, your Lambdas, your whatever is processing your data, it should be as code. Even though you may work with tools like we do, like for example, there are some UI tools, data factor or whatever, which you can drag and drop like boxes and it will process your data. But still these tools have like allow you to export the configuration and it should be exported and considered as a code. Finally, after having this infrastructures and pipelines are running, then you have to transform into code all the changes that you do in your databases or in data lake. So if any schema changes or metadata changes, what is schema change or metadata change? You add new field, you change field type, you grant access, even like this type of things. You create a view or you create a table, whatever is it. It should be written as code, and you should see, okay, at some point we had a new data analyst, we granted him this access, he had delete access, he dropped everything, okay, we know why it happened. Not that one day you wake up and your database is gone or some new field is there, nobody knows who created it. And this fourth one probably is one of my favorite ones. So why it's one of my favorite ones? So, you know, like as data engineers, these steps are quite common for us. We are still in a software engineering discipline, but we work a lot with data analysts. The data analysts, they create reports, they create analyses using SQL quite often, or maybe even Python, whatever. But what they do, they just, I don't know, they just write this report, maybe they save it as a procedure or some view in the database, and that's it. There is no PR, there is no code review, it's very hard to, and usually it's even deployed manually, quite often this happens. So, because like it was Excel, now it's a database, and I mean, approach to this, it's not like usually in software engineering. But with current tools, such as, for example, DBT, data build tools, and I think others will also emerge. Not only we have new roles like analytics engineer, and so it's like closing the gap, but also we have option to bring data analysts to the same process as data engineers and software engineers. So what it allows to do. So as with that types of tools, you can have your SQL code written, like a data analyst creates a PR, like create some report, write tests. Also, reports and analysis become testable. And then he or she creates this PR. This, again, we have continuous integration, tests are running, somebody reviews this, everything fine, approved, deployed, and this report is in your dashboard or in your database. So not only these tools are like helping people to like transform data with SQL or whatever, Python, using compute resources of the database or other distributed system, but they bring us in under same process. And from my experience, all data analysts like this very much. It levels up and they start to understand, okay, why we should use Git, why this is important, and how it can help them go back and see, okay, this report is wrong because I had the bug, and that's why, not because, okay, where is this data coming? It's a problem in database, it's in report or dashboard. So, and finally, this dashboard as code. So this one is probably the last edition, and we should say thanks to ChatGPT and similar technologies for this. Maybe it's not obvious why, but I will explain. So as a DevOps, maybe you know there are these tools like Grafana or whatever, just to create, or Kibana, create a visualizations. They are nice, but they are not the main tools that data engineers, data analysts, and data scientists use. We usually use this Tableau, Power BI, and this kind of dashboarding solutions. But these solutions are like, you do everything manually. You have this desktop client or maybe in the web and use drag and drop and like create these pie charts and whatever. So what happens, like you do everything in code and then somebody starts manually to build all the stuff. And if something goes wrong or if this dashboard is broken or lost, it's gone. So you cannot recover it. Somebody have to do it manually. And also you cannot like deploy, you cannot have, okay, connect your dashboard to dev environment, connect it to test, and it's very complicated. But what happened? So basically, as you know, now there's this Copilot and other assistants, they are trying to help us write code and automate a lot of stuff. If you have only a solution which is manual and maybe has very like cryptic underlying configurable files or like language, very cryptic one, then you cannot learn this. You cannot learn on like train your model on this, and so it cannot also like help you add visualization. It's very hard. But if you translate all these graphs and visualizations into readable code, maybe something close to what we write, if it's Python, JavaScript, or whatever, then we can train on this code. And then these assistants can help us create the visualizations or improve something in our dashboards. And thanks to that, finally, we can see that now, at least I see it starting from this year, these dashboarding solutions also are offering, you can create a project and write code, and then it will compile it into the dashboard. And then you can use all the functionality that we had before. So this is the probably latest thing, and next year it will be very common to have a Power BI or maybe also Tableau project where you as a data engineer maybe will enjoy writing code and not like, okay, like changing colors. Especially, for example, it's important because, for example, we have a dashboard, it has 12 pages, each page has maybe 15 visualizations, and then we decide just to change one minor thing or one slicer on all these pages. Manually, you will do, you can multiply and see how many operations, and maybe you will miss something. In this, I will do just search, replace, and dashboard is ready. So this is about everything as code. So this is the foundation for the next step to embrace the change. Because obviously changing the code is evolving, all these components are changing. So now we have everything inside code, and then we can track it. But now we should be able to test everything, and we should be able to deliver all these changes. So first of all, we should have corresponding environments to test both code and data separately. What this means? So in usual setup, like if you have a backend service or whatever, not data engineering, if you found a bug, you change it, and then the request that user is getting, the page refreshed, it's correct, and so on. But in data engineering, if something was wrong from time point 1 to 2, at this interval, everything is wrong. The data is corrupt, it's gone. You don't have this data. And also, what happens quite often, not only you may not change the code, but somebody upstream in other service that you get data, they change their code, and then everything breaks on your side because they changed their code. You didn't change your code on your side, and your pipeline doesn't work with this code. So how can we avoid this situation? So for the beginning, you can start with the environments that other services that you are working with have, like dev, staging, production, and so on. What this will allow you to do, so you can start with dev, where maybe you consume the data from dev environment, maybe not, or you synthesize this data, but basically here you can just test your code, your pipeline. Is it working correctly? You don't care about data. Then you take this correct working data pipeline and put into staging environment, where you have real data and the code that you want to test on real data. And finally, when both code and data, they work correctly with new code with real data, then you can move to production. Also, what this is helping you to do, as I said, you depend on other teams as a data engineer, always. It's very rarely that you just generate data out of nowhere. So And the communication doesn't work always. So if you rely that, okay, that the backend team or client teams, they will come and say, you know, by the way, in a month, we will add new feature and it may affect you. It never happens. Nobody will tell you that. So you have to take care of this. So one solution will be like you work with them and establish some type of contracts, whatever, like if they change the schema, you get notification, whatever. Or you just have these environments where if they change, you in your dev or staging environment, which is connected to their corresponding environment, you get this alert or all the errors, and you say, okay, something is going on, so they're changing something. And then you go and ask them, are you going to change something? They say, yes, okay, then you can complain a little bit, like to talk to management, but, and then anyway, you know that something is changing, so you can take care of it. So another thing is how we work with this environment. We don't do manual changes. We don't touch them and so on. We use our CI/CD process, which is relying on previous stage. Everything is in code, which means we can deliver everything automatically. We use CI/CD to deliver everything. This one part is short. So, and finally, how do we ensure that everything, we must ensure that changes in code create expected changes in data.
Mm-hmm. Just before that, so do you suggest to use the staging environment where you have the actual or the copy of the actual data for tests, for testing, and also automated testing?
I suggest that the staging environment is either should be connected to say the staging environment of the like backend or client that you are consuming from. Or if you don't have this opportunity, let's say they don't have it, maybe, or whatever, then you can have staging as a real data, production or subset of production, and then work with it. Because until you go to production data, you cannot catch these issues. That's what I was suggesting.
You have automated tests running in the staging.
Yes, everything. You should have also the monitoring that I will talk about. You should have this test and monitoring on staging as well. Because if you catch the alert, if something breaks, you know that, okay, it breaks in staging, we got alert, maybe we just don't wake up at middle of the night, but then we come and fix and talk to people. So because you should have processes instead of communication. Communication usually fails. And this is also about third stage. Third one is also about that. So you, after deploying something, you should make sure either just checking your dashboard, checking your alerts, or having some period of time that it's running in this environment, that these changes are creating corresponding data. It doesn't reduce data, doesn't increase, and so on. Well, everything is expected, either by running some tests, maybe additional tests on top of this, or just a monitoring system for some time before you move to the next environment. Okay, so now we kind of finished the part where we did everything we can to prepare, so we can start, build a solution with all these concepts, and that will help us to guarantee all this it will create all the safety and the quality, guarantee to have a higher quality solution before. But then you deployed your solution, it's working. So you have a solution in production, or maybe it's not from scratch, but it's already there. So this is the second part that we focus on after delivering solution. I split this data monitoring part into two parts. First one, I call it data agnostic monitoring. So this is the thing that quite often data engineers do. And you treat this data as some fluid water which is flowing through our pipelines. You don't care about its chemical properties, you care it's about physical properties. Why? Now you will see the analogy where it works. So first of all, you make sure everything works, these pipelines and so on. So, which means you make sure your database is up, the CPU is not high memory usage, disk is not full, all the stuff that you check in all other projects, not even data engineering. Then you check if you don't have any You don't have errors, which is the best case, but or you have acceptable rate of errors. What is acceptable rate of errors? So for example, especially in streaming situations, you have a stream of events, and this sometimes you get some weird events, which for some coming from some very old version of your application or whatever, and it's okay. It's expected that you will get them. You have just to clean them, or maybe you try to ingest them, and if not, you put them somewhere aside to analyze later. This is also okay. It's not that you should have like 0 errors and it's ideal, but everything should not stop just because you had 1 or 2 errors. And the third obvious thing, you should make sure that your pipelines actually work. They not like fail on each stage or whatever. So it looks like everything works. And then you start actually to analyze other properties without actually looking into data. You just, the second thing you try to understand, is your fluid, is your data flowing as expected with the same rate as you receive it, or it's like slowing down, maybe at some point you have everything is stopped, or it's very slow, like how you do that. So wherever the data is generated, then you process this data, right? You may have a streaming platform like Kafka or whatever, or just some batch process, and every system may have a bottleneck. So what happens? So maybe you have just one consumer, and then your producer, 10 more producers, and this one consumer or even 2 consumers, they're like not catching up. So something happening, some new data is coming in, but not enough. So this is what I call this, like you should the like lag or latency. This is not the lag that this data was generated. It's with the property of system, like somebody was offline and we get event later. We will talk about that. This is the lag because of your system performance. You should make sure that there is not this type of lag or latency. And finally, again, another property, physical property of your data, that its volume is consistent across end-to-end systems. So you have, for example, first pipeline, second one, or one database, another database, it's copied from one place to another. And you should make sure that if here you have like 100 million events, then next stage you have 5 million, it's result of aggregation, not that just, for example, what can happen? Very simple thing. Again, somebody introduced new event, or they changed the version, and you don't know that this is also a valid version number or whatever, and you just dropped it. You just drop it, and you just collect all the old version events, like the ones that you knew about or something like that. And this is not good type of data volume reduction. Or maybe you just get some data and you unfold it and you get 10 times more than expected, but they are duplicates, something like that. So you make sure this fluid flows as expected, no problems. You don't know anything about the fluid. No, maybe you know something, but not very much. You don't know, okay, what value should have each field and so on. And then we start to actually look into data. So when everything is long, this part we don't like. As a data engineers, we don't like this. I don't like it. So that's why maybe it's also boring. But you should do it. Yeah, it's useful. So because these business people, because what happens, it's very often like you did it, everything works, and then you show this to people, and especially there are some people from maybe management, from product, CEO, especially always there, you will notice the first error. And he says, oh, this metrics looks wrong. For you, it's like, why it's there? Why it's wrong? It's a nice metric. Why it's wrong? And then, obviously, then you see that, yeah, if you dive a little bit into domain and even maybe just some simple checks, then you see, yeah, that doesn't look good. That's why it's very important to then look into data and do data quality check. So what is data quality? It's like we can say that it can be defined with these 3 characteristics. So accuracy, completeness, timeliness, or I sometimes call availability. So what is accuracy? Accuracy, it makes sure the data is not duplicated, the value is correct within the correct range. So integer is integer, string is string, and so on. So basic stuff. Completeness is when you have, let's say, a record, a row or event, and then you make sure that all the required fields are there, and even the ones that maybe are not so much required, but you don't want them always to be null. If you are collecting them, then probably you need them. And finally, the timeliness is the one that I was talking, that the data is arriving as expected. It's not like that when you see that, okay, we don't have some data for 2 hours. Everything is flowing, but this data is not there. What is the reason? Maybe some other dependency is not sending this data. Maybe something was released that is not sending, or maybe something is offline and we don't get this batch of the data. So data should be arrive in timely manner or should be available. So, and next thing is you can do this and the previous step and it still not be enough. So why you can do this step? As this we don't like as data engineers, but data analysts, luckily they like it. And some mostly like it. So they do it. So as a data engineers, we do the previous step, everything flows, we say everything is good. And the data analysts create a table, view, dashboard, they say, look, it's nice, and even print screen it, they show it like everything is good. Everything is good for them at this moment, and for us, everything is good just flowing. But it's not enough, because quite often, like I had even a case when we did a test, there were no duplicates for 3-4 months, and then we even say, forget about it, just don't even, we forgot naturally, we didn't check for that. I mean, we were generating all the reports for duplicates, but we were not looking into reports. Like you may have a dashboard, but you don't look into dashboard. That's also a common thing. So, and the final thing I wanted to talk is like proactive data quality. It's not a term. I just try to say the things that it doesn't sound only like this trends, like big data or whatever, because the trend's name is data observability. So it's now becoming trend. We will talk how they define it, but as you will see that it's combination of two things that we discuss. So if we take monitoring and we take data quality, so if we monitor data qualities, then we will get data observability, so we can proactively monitor it. So if something breaks, we know it. So the like 5 pillars or 5 sections for the data observability are the freshness. We discussed the freshness is like we want everything to arrive in time and be available. Distribution or quality, again, we want everything to be accurate, in correct ranges, no outliers, no strange values, so on. The volume of the data should be persistent. Again, we don't have anything dropping. This, by mentioning schema, it's more about not just schema, only schema, but any change in your metadata, we can say. New fields or new event types and so on. So if there's a change, we should know about this change and monitor this. So if you got new field added, you should know about it. And probably the most important one of this is the lineage. And the lineage is, we should know when something breaks, where it breaks, and who was affected by that error. And that we can do only by doing everything that I discussed. So you know all the code, when it was changed, who changed, in which part, who is depending on this solution. It's also you can have this organizational data. And when you find this, you got this alert, you can go and track and find out, okay, who did that and why this happens now. So all these 5 will give you this data observability, or which is for me just active data quality. And how can we build some simple data quality solution? We can buy it. It's obviously a big growing industry or part. If you check this state of data engineering for 2023, there are, I don't know how many, but a lot of tools which are doing exactly that: data quality, data observability, and so on. The Great Expectations is very popular, Kensu, this Dataful, Monte Carlo. But there's one thing that is uniting them all, I think most of them. It's the secret ingredient is anomaly detection. So basically, if you have monitoring on top of your data quality, you have to watch it to see if something breaks, and you should know what is not okay and what's not. But if you add anomaly detection, which is very basic thing for you as a data scientist, machine learning specialist, you don't need to invent it. You probably can use some service which already exists. Then you can detect anomalies. For example, you can see, oh, this field was available for 80% of the time. It was not null, and now we are seeing this field is available only for 10% of the events. So something is wrong, and just by looking, maybe you will notice, but if you have hundreds of fields, probably you will not notice. That's how your anomaly detection will help you. Or you see that, okay, the CPU usage went up, disk usage maybe, whatever property of your complete system is, you can see that. But the same applies for data quality. And here's the very simple solution that we use in our team. It's not important what are the actual technologies, so I will explain, but it's not important. So first of all, it's important that you have some data, the time series data. Time series means it arrives timely manner, so each field has maybe timestamp, so time is one of your dimensions. Then you detect anomalies, then you send an incident for, like it's an email, maybe you send something in a Slack or whatever to corresponding team that, okay, something's wrong, and then the team can come and analyze if this tool allows you to do like root cause, or maybe you will do root cause analysis yourself. So what can be in your case? Anything. In our case, it's Azure Data Explorer. It can be whatever, Elasticsearch or whatever, where you collect all the data, even your database. Can be even Redshift or whatever. And then you have we have the Metric Advisor, which is a cognitive service. It's just a anomaly detection service. Very simple. It works for that very well. Just nothing special. And whenever this service is querying our database periodically, like maybe each 10 minutes, maybe each hour, maybe each day. And whenever it notices, oh, we have something that is outside of the boundary, which is like say sensitivity, then it sends us an alert. Very simple. And with this, we are able to notify and catch all the bugs that not only we are introducing, but all the teams that we are depending on as a data team, as a consumer, they are also introducing. So this way, you also can help your backend team to detect that. Because backend teams or client teams, they are not very much looking into data as long as it's functional, as long as user doesn't have any specific issues or tests are working and so on. It's not very important. Maybe, okay, this user, we have strange increase in the or drop in the some of the fields for the users. If everything works, maybe you will not notice. But with this solution, you will notice, and then you will contract and say, by the way, on our website, this form is not working, and people are not introducing this data, for example. So yeah, this is the last thing I wanted to talk about. So definitely you should have your data quality in place, and it should be automated again, as everything we discussed. It should not be like you just look after you build something. It looks good because data is degrading and systems are also degrading. Yeah, I think that's it. Thank you. You can ask a question.
I need some time to construct the question.
Mm-hmm.
So usually continuous integration implies not only that you integrate the code continuously, but also you are sure that these changes do not break anything. And in software engineering, this is usually done via testing.
Mm-hmm.
There are the two main approaches for like data engineering testing that at least I know. The main ones are like either synthesize the data
Mm-hmm.
and then like run your data quality checks, or just see like in smoke testing that everything works correctly,
Mm-hmm.
or maybe sample or even snapshot your production data and basically do the same. But once you get to a point of like thousands of pipelines, data pipelines, the first approach is too labor intensive.
Mm-hmm.
You cannot do this anymore. Like it's too hard to find time of data engineers to like synthesize all the data, make sure that like everything is correct, and then once you introduce change, you have to change also these data mocks, and that's hard. And the problem is the second one is usually security concerns. You should not really cross your data between different environments. So my question is, do you have any insights on how to do
I think each time for each case with all the restriction, you should try something, adapt some solution. So basically, you write some unit tests, as usual, the simple ones, and in unit tests you try to handle corner cases of the data can be. Then it's not enough. Unit test usually doesn't catch much. But then you want the real integration test. And for the integration tests, for example, with, let's say, this DBT or the tool that is creating report, you can create a report in like dev schema or dev environment, dev database, which has some data. It's dev data or stage data. It has the data, and then tests are running or already created table. And after that, if the tests are fine, you get like, okay, these changes that introduced, they are working fine. This is the case of, for example, the report. For data pipeline, you should try to, again, have some, you should have some data in each environment. And you use this data to run these tests. Because if you don't have the data, like in dev, you definitely have. In stage, you also have. It's not crossing the boundary. On each stage that you are merging to each branch, let's say it's a dev branch, it's staging, and then it's master. It works with the corresponding data of that environment.
Yeah, but that means that like you have to also maintain this data samples in your dev environment. And that can be really expensive.
It's expensive if you don't have some upstream. If you can integrate with other sources which are also doing some dev stuff, then like if you have a backend system, it's cheap, because they have already the dev data, and then you can use their dev data. If not, yes, you have to kind of create this, synthesize it, and then you decide how much you want to invest in this stage, in contrast to maybe final stage when you merge everything and then check that on a staging data or whatever before going. So it's a compromise. It's very hard to achieve in every situation all these parts, ideally like in software, because again, we have the data, and the data, it can be huge, it can be diverse, and so on. It's not just one function, it transforms this functionality. So you should be creative there in each one. So I try to, even with infrastructure, each your PR should try to apply this and these changes, and then you get error. And then you say, okay, this we cannot do this update for infrastructure. But sometimes even it can pass, you can merge, but then when you try to merge it to master, it may fail because, for example, I don't know, in your dev account, there were no limitations, or there were no limitations on number of, I don't know, buckets or whatever. And then you go to the other environment, you still have limitations. So, again, it's I would say, combination, like it's a balance between CI and CD. How much you do test in CI and how much you do test in CD after deploying.
Using different granularities to have some low granularity test. In some cases, high granularity test to see. Not to test everything in the data, but these comparisons will give you the idea that, for example, this part of the code is broken and there are data coming that's an anomaly. So we should double check it's more data, it's changing the, I don't know, client's behavior, that's the source of the data, or the data pipeline is broken.
If we split, yeah, if you have data, you can decide. For example, we sometimes for some data we do an hourly for daily. But if we talk about anomaly detection, generally in this case you don't have to keep all the data. You can work with the recent data, because if very old data, it will not help if you find something anomaly. Only it will help that you can go back and see after you fix your issue, did it come back to the original baseline? Let's say you had some corruption in your data, and did it return to a new, like old values? Only that. But usually you are interested, I don't know, for this type of monitoring and alerting in maybe 1 week data is even enough. So you have this 1 week data or 2 weeks. So you have the seasonality of the data, and then you can your anomaly detection will work. And yeah, granularity you can decide if you don't want to like alert on every small like 10-minute change if it's not really important for you. Yeah.
Can you share some success story of explaining data analytics or meta-analytics that it's better for them to make PRs, but not make a shadow.
Yes, well, actually, that's what was one of my previous, before Microsoft CRISP, we exactly implemented that. So we didn't have data analysis at that moment, and I heard that there is this DBT tool, but I didn't know what is it. And then for me, the magic of DBT is not that you can write a SQL and transform all the stuff. No, that you can create these PRs and automate the things and put code in. And the explanation was that for them, we did all the setups. They don't have to like, we just explained about his Git, how nice it's.
They still don't understand it.
No, they actually start to understand. They understood it, and then I know that they were happy that there was such setup. Because it allowed them to revert, go back and check what was maybe wrong or what was missing. And each time they were looking into the Tableau, they knew that, okay, this is this latest version. And what we also did, there were one complaint that initially we had the monorepo and data engineers and data analysts were working on the same thing, but they didn't care about this like dev or they had very more simpler like stage and prod, kind of a setup. They didn't want it to wait for our approval and so on. So we separated, and data engineering projects were separate. They only had one DBT in their DBT project in their repo, and they moved faster than us. But this way, then they were happy with this, and the process was quite simple. So I think I got feedback that they were enjoying doing that. I don't know. I think you need to show the best parts of, because initially in other company I tried to convince to use that, but since I myself didn't implement it and I didn't know all the good parts, I couldn't convince them. You should do it as a data engineer yourself and then present them in the easiest way. So like not to have a steep curve, a learning curve for them. Start from the, and I also had all the basic reports I did myself so I can understand what problems they can. And I gave them kind of skeletons. I said, okay, if you want a report, you put it in this folder. If you want some ad hoc analysis, put it here. Maybe you will need later, and so on. So after that, they started to like grow it, and now it's quite huge, as you know. Mm-hmm.
As you have mentioned in your slides, like now it's launched that reporting is also possible to generate in a code, right?
Yes, not reporting, dashboard.
Oh yeah, dashboard.
Mm-hmm.
So do you mean that like data analysts should like keep all of this in code, or just like data engineers should do it?
It works like this. You can export your project, which you maybe create. You do it change manually, but then you can save, and it will create a commit inside the code. You don't have to go and write this code, but you have this both ways to go. So you either work manually, and then if you, as I said, you need to change a little thing everywhere and so on, or copy paste, create new page, you go to code part and do that way. Maybe there is no data engineer interacting with this, but this way you can, and on top of that now also there emerging support for deployments, pipelines for dashboards as well. So you deploy to dev or test, whatever it's called, which is connected to test data. Here you test just the dashboard, you don't care about the data. Then you take this dashboard and test with the actual data, and you make sure, okay, this dashboard works with actual data, and then you release it to prod. Again, what is good about this, you don't save something in your dashboard and everybody sees this, because usually in Tableau or you publish, everybody sees that, but you don't, sometimes you want to publish and just share with the team. You don't want to create new dashboard for team 1, for team 2, and then after it's correct, you publish to everyone. You can go through the stages even with dashboards now. I don't want to advertise Microsoft or Tableau or whatever one, because if I say this one allows to do that, maybe in 2 weeks or 1 month, another, we will see that there is also support from other vendors.
It's already implemented in Tableau, right?
In Power BI, I saw that, but in I didn't work with Tableau for 1 year or more, so I cannot say. But I saw in Power BI that it's working like that. I think we're done.
Yeah. Thank you one more time.